All right, Algebra 1B students, welcome to Chapter 10. We are moving on a little bit from quadratic functions where we had an x squared. We're going to talk mostly in this chapter about radicals, meaning square roots. So we'll talk about a lot of different square roots. We're going to start here in lesson 10.1 by getting a little bit geometric. We're going to look at triangles and the most common and well-known theorem in geometry called the Pythagorean theorem. It's something I believe you have already talked about, already learned about, but we're going to do it again in this class and see how it applies to square roots and radicals. A couple vocabulary things before we get going. When we have a right triangle, there are special names for the sides of those, for that right triangle. The one that is across from the 90-degree angle is called the hypotenuse. So if you look here at this example, my 90-degree angle is always denoted with a little box, meaning that's 90 degrees right there. So if I go from there all the way across the triangle, obviously I end up here. That side is called the hypotenuse of the triangle. The other two sides, this guy there and that guy there, are called the legs. So you have two legs, you have the hypotenuse. The hypotenuse is always the longest side. It's the one all the way across from the 90-degree angle. It does not touch the 90-degree angle at all. The Pythagorean theorem relates the legs of those three sides of a right triangle by saying this. A squared plus b squared equals c squared. I think that's a formula that's familiar to you. But a squared plus b squared equals c squared. Now, the c squared, this guy right here, is always the hypotenuse. C squared is always the hypotenuse. A squared and b squared can be whichever sides of the triangle, whichever legs of the triangle you want. This could be A, and this could be B, or this could be A, and this could be B. It really doesn't matter. The A and B can be switched around however you want. But the C must be the hypotenuse of the triangle. So A squared, meaning this side squared, plus this side squared, has to be equal to the hypotenuse squared. Again, squared just means multiplied by itself, right? Okay. Now, the type of problems that you will see in your practice problem set are going to say something like this, where they might show you a picture to tell you this same information. What is the length of the hypotenuse of a right triangle with legs that have lengths of 9 centimeters and 12 centimeters? Well, if I draw myself a quick little picture here, there's my right triangle. I know that my two leg lengths are 9 and 12. I want to find what is my hypotenuse length. Right? What is my hypotenuse? Well, I'm going to put the information that I know into the Pythagorean theorem and solve for the one that I don't know. Okay, so in this case, it looks like this. A squared plus b squared equals c squared. Okay. Now 9 squared, 9 times 9, that's 81. 12 times 12 is 144. That's equal to c squared. Okay, so now I'm just simplifying the left side of that equal sign. Simplifying all of this stuff. (81 plus 144 gives me 225 equal to c squared. Right, so I just added those two together, and that's what's equal to c squared. Now, if I want to get the c all by itself, I need to undo the squaring that I've done in my Pythagorean theorem. We have a symbol or a function that will undo the squaring for us, and it's called the square root. So the square root of 225 is equal to the square root of c squared, but the square root of c squared is just c. So all I have to do to get c by itself is square root 225. If you did that on your calculator, you would find that the answer is 15. So my hypotenuse length is 15. Now that's good news. It should be longer than both of the other two sides, because I added those two up after squaring them. And then I took the square root and found that my hypotenuse length is 15. Okay. Now you may also see problems that look like this, where again, they want us to find a missing side of this triangle. This time they want us to find b. That is not the hypotenuse of the triangle. This is the hypotenuse of the triangle. The 13. So when I put my side lengths, 5, b, and 13 into my Pythagorean theorem, it looks a little bit different. Now it's 5 squared plus b squared, which I still don't know right now, is equal to 13 squared. Okay, and again, I'll just simplify and try to solve. I know that 5 squared, 5 times 5 is 25, plus b squared is equal to 13 times 13 is 169. Okay, now I would like to solve for b squared, or for b, so that I can find my missing side length. First, I need to get rid of the 25 that is attached to the b squared. So I will take away 25, take away 25. So now it's gone over there. Now all I have left on the left side is this, b squared. All I have on the right side, once I simplify, well, right now I've got 169 minus 25. 169 minus 25 is 144. Now again, I would like to get b all by itself, which means I need to undo squaring b. My function for that, again, is square root, like we were working on yesterday, right? Or earlier today. So when I square root b squared, all I have left is b. I undo the squaring stuff. That's equal to the square root of 144. If I do that on the calculator, you find that that's 12. So b is equal to 12 centimeters. We should put our units on if they give it to us. So there, instead of adding two numbers together, I subtracted them, right? I subtracted them right here. So, if you have questions about that, make a note to ask me in class tomorrow. I would like you to try this problem here. What is the side length of letter A right here in this triangle? Try this one on your own. So pause the video, try that problem there. Once you're done, come on back and play the rest of the video. I'll show you what we should get for an answer there. Okay, pause the video, take a look at this number 2 here. What is that side length A for me? Okay. If I put my numbers in the Pythagorean theorem, I don't know what A is right now. My other leg is 12, and my long slanted hypotenuse is 15. If I simplify these numbers, I still have A squared. This is 144. This is 225. I subtract 144 to get the A squared alone. Minus 144. So A squared is equal to 81. A is equal to 9 or negative 9, right? We just took a square root, so it could be positive or negative. I didn't do that earlier, but here's why. This answer doesn't make any sense because we cannot have a negative side length. We cannot have a negative side length. So obviously our answer is 9. If you have questions, make a note to ask me in class tomorrow. Otherwise, that's all I have for you right now. Have a wonderful night.